Welcome to Unacademy. Good evening, all. Good evening, ready? How are you? Raju, good evening. How are you? Welcome to Unacademy. ఏ వాయిస్ క్లియర్ ఉందా వినిపిస్తుందా అందరికి Raju, ready? Okay, please comment about voice. Is it clear or not? Raju, నేను బాగున్నాను రాజు. ఎస్ నేను కూడా బాగున్నాను రెడీ. నిన్న ప్రాబ్లమ్స్ చేశారా? పవర్ ఎలక్ట్రానిక్స్ లో బేసిక్ ప్రాబ్లమ్స్ ఉన్నాయి కదా లాసెస్ పైన. Very important problems. Yesterday we had discussed that part. Okay, so let's start the session. Welcome to Unacademy all. My name is Bhanu Prakash, expert in GATE and ESE. I did MTech from NIT Kurukshetra. I have 10 years of teaching experience and I train many students for GATE, ESE, Transco, Genco and many more electricity board exams. And my subjects are electrical machines and power electronics. And this is a BPC 10 is my code. Okay, get 10% of discount on Unacademy plus subscription. Okay, the last date to take the subscription here, the 20. So after the 20, the subscription fee going to be high. So that if you want to take the subscription, take it as early as possible. Okay, only 2 days only. Okay, today and tomorrow and day after tomorrow. 3 days, last 3 days ఉంది తర్వాత ఫీ హైక్ అవుతుంది 40%, నియర్లీ 40% ఫీ హైక్ అవుతుంది. సో ఇప్పుడు 20,000 ఉంది కదా, నియర్లీ 35 చేంజ్ అవుతుంది. సో ఇఫ్ యూ వాంట్ టు టేక్ ద సబ్స్క్రిప్షన్, టేక్ ఇట్ యాజ్ ఎర్లీ యాజ్ పాసిబుల్. ఓకే, నాగేశ్వర్, గుడ్ ఈవినింగ్. And what are the subscriptions on Unacademy? One is the plus subscription, and second one is iconic subscription. And benefits of the plus subscription: live classes from the top educators. Okay, you will get a live class for any subject. Okay, we have a choice of the teacher. You can select the teacher by your choice. Okay, and also structural schedule. So this is available for 3 months, 6 months, 12 months and also 24 months. And unlimited practice questions. Okay, this is the unlimited practice question for subject wise, topic wise And this is a very important if you want to write test series. So this test series also involved in the plus subscription, so that if you want to take the subscription, that take it there as early as possible, last 2 days. Otherwise fee will be going to be high, so that it will be expensive for you. So and one more icon, the another subscription is iconic subscription. సో దీంట్లో ఏం బెనిఫిట్స్ ఉంటాయి? వన్ ఈజ్ అ పర్సనల్ కోచ్. ఒక మీకు పర్సనల్ గా ఒక కోచ్ అసైన్ చేస్తారు. ఒక ఈ కోచ్ మీకు ప్రతిదీ గైడెన్స్ ఇస్తాడు. సబ్జెక్ట్ ఎలా చదవాలి, ఓకే, నెక్స్ట్ మీరు ఎలా ప్రిపేర్ అవ్వాలి, ఒక్కొక్క సబ్జెక్ట్ ఒక దెర్ ఈస్ ఎ సమ్ వే టు ప్రిపేర్ వన్ సబ్జెక్ట్. ఫర్ ఎగ్జాంపుల్ ఎలక్ట్రికల్ మిషన్ ని ఒక మిషన్స్ టీచింగ్ ఒకలా ఉంటుంది, పవర్ ఎలక్ట్రానిక్స్ ఒకలా ఉంటుంది, ప్రిపరేషన్ కూడా సేమ్. So me is personal coach. You will we will assign one personal coach. He will guide everything. And one more is a study planner. సో మీరు ఏ సబ్జెక్ట్ చదవాలి, తర్వాత ఏ సబ్జెక్ట్ ముందు చదవాలి, తర్వాత నెక్స్ట్ ఏ సబ్జెక్ట్ చదవాలి, ఇవన్నీ కూడా మీకు ఐకానిక్ సబ్స్క్రిప్షన్ లో మీకు ఉంటుంది. నెక్స్ట్ వన్ ఎక్స్పర్ట్ గైడెన్స్. ఒక మీ యూ విల్ గెట్ సమ్ ఎక్స్పర్ట్ గైడెన్స్ అండ్ ఆల్సో ఈఎస్సి మెయిన్స్ క్వశ్చన్స్ అండ్ ఆన్సర్. ఓకే, ఈ మీరు ఒకవేళ ఐఎస్ఏ ప్రిపేర్ అయితే మీకు ఈఎస్సి ప్రాక్టీస్ క్వశ్చన్స్ ఉంటాయి, దానికి మేము సొల్యూషన్స్ కూడా ప్రొవైడ్ చేస్తాము. ప్రతిదీ కూడా మీకు ఎక్స్ప్లెనేషన్, డీటెయిల్ ఎక్స్ప్లెనేషన్, అనాలిసిస్, అంటే ప్రాబ్లమ్స్ ఎలా వస్తాయి, ఇవన్నీ కూడా నీకు ఐకానిక్ సబ్స్క్రిప్షన్ తీసుకుంటే మేము ప్రొవైడ్ చేస్తాం. Okay, if you want take the subscription, take it as early as possible. Okay, and next, what about the payments method? This plus subscription is available for 6 months and 12 months and 24 months. The fee structure for 12 months is a 25,000 rupees. Okay, and if you use my code, that is BPC10, okay, you will get 10% discount. And after the discount you have to pay 22,500 rupees. And this iconic subscription is available for 12 months only. The fee structure is 45,000 rupees. Okay, what about the code? If you use my code, suppose BPC10 is my code, use this code to get the 10% discount on Unacademy subscriptions. Okay, in case of plus subscription as well as iconic subscription. And what about the payments method? We can use any cards like credit cards and EMI cards. So like ICIC, HDFC, Axis and Kotak. సో పర్ 3 months ఈఎంఐ, సపోజ్ మీరు 3 months ఈఎంఐ తీసుకున్నారు అనుకోండి, దాంట్లో మీరు ఎంత పే చేయాలా? 7,500 రూపీస్ పర్ మంత్ పే చేయాలి. అలా కాకుండా మీరు 6 months ఈఎంఐ తీసుకున్నారు అనుకోండి, సో దీనికి మీరు ఎంత పే చేయాలంటే 3,750 రూపీస్ పర్ మంత్ పే చేయాలి. సో ఒకవేళ మీరు 9 months ఈఎంఐ తీసుకున్నారు అనుకోండి, సో దిస్ ఇదే పర్ మంత్ ఫీజ్ 2,500 రూపీస్ పే చేయాలి. ఒకవేళ మీరు 12 months ఈఎంఐ తీసుకుంటే 1 year లో ನೀವು 12 months ఉందనుకోండి, ఈఎంఐ ఎంత ఉంటుందంటే 1,875 రూపీస్ ఉంటుంది. సో దిస్ ఈజ్ మై కోడ్ BPC10 referral code. You will get 10% discount on the subscription. So after after the discount you have to pay 22,500 rupees. Got it my point? All of it clear? Okay, is that clear everyone? Yes. Bhargav, good evening. Pawan, good evening. Joseph, good evening. Hi. Okay, good. Very good. Okay, listen. So previous class we had discussed about basics of power electronics, and also so what are the characteristics of ideal switch and what are the characteristics of the practical switch. So what is mean by power electronics? What why power electronics? Okay, and what are the advantages of power electronics here? So advantages point of view here by using the any power electronic device, so that is a power losses, okay, are very less here as compared to the any other electrical equipment here. So power loss are less, the losses are the less. So what are the power losses in the any power electronic device? Yesterday we have discussed, that is a so conduction loss, okay, and second one conduction power loss, okay, blocking power losses, and third one is a the switching power loss. Okay, these are the power losses here. So what about the conduction loss? Conduction loss means wastage of the power during turn on state of the device. Blocking power losses means wastage of the power during turn off state of the device. Switching power losses means the here in order to turn on the device, some amount of the power is a wasted, okay, in the form of the heat. So that power losses is known as, or some amount of energy is wasted to turn on the device, some amount of energy is wasted to turn off the device. So these power losses are known as a switching power losses. Got it? So how do we calculate this power loss? Yesterday we had discussed, and also what is the equation for the positive slope of the equation, and similarly negative slope. Okay, the straight line equation with negative slope, the straight line equation with positive slope. Okay, very important formulas yesterday we had discussed. Okay, all of you got it? Yes. Okay, listen here. So today we will discuss about classification of power semiconductor device. Okay, and what are the power semiconductor device? We had discussed that part. One is a first device, the first power semiconductor device, that is the power diode. Okay, here first one is the power diode, and second one is a SCR. Okay, SCR means silicon control rectifier, and third one is a GTO, gate turn off the thyristor here, and fourth one is a triarch. Okay, this is also one more power semiconductor device, and fifth one is all the transistors. So that is a the power transistor, power BJT, the bipolar junction transistor, and sixth one is a power MOSFET, okay, metal oxide, the semiconductor field effect transistor here. So that is the power MOSFET. So next one, seventh one is a power IGBT, okay. So insulated gate bipolar transistor, okay, this is the IGBT here. So these are the main devices in the chapter 1, that is power diode, SCRs, GTO, triarch, power BJT, power MOSFET, power IGBT. So all are, okay, this all the devices are used as a switches. Okay, the all the devices so used as, okay, used as bistable switches. So that is on and off state. So bistable switches to control, okay, already I mentioned yesterday. So to control and conversion of, okay, this is the conversion of electrical power, conversion of electrical power from the source to the load. Okay, this is the function. So from the source to load. Okay, this is a S means that is the source to load here. So got it point. All the devices, all power semiconductor devices are used in the power electronics. Okay, these are in the only in power electronic applications. Okay, power electronic applications here. So that is a power electronic applications point of view. So that is a all the devices are used in the bistable switches, that is the on and off state switches, to control and conversion of electrical power from source to the load. Suppose here these devices used in the electronic analog electronics for amplification, not about the switching actions, but in the power electronics this function is a only on and off to control conversion of the electrical power from source to the load. Okay, so this is a main function of the power semiconductor devices. Okay, all of you clear? Is that clear, everyone? Okay, please comment on the comment box. Okay, is that clear or not? Very good, Pawan. Okay, so now how do we classify? So these device, these are the seven devices are there in the power in the first chapter, and how do we classify these device here? First one in the first classification. Okay, let us take this one is a, so that is a classification. Okay, this is the classification, the one. So how do we classify these devices here? So these devices are classified. Okay, these device or switches are the classified based on. Okay, these devices are classified based on the controlling of on state. Okay, are getting my point? So this is the devices controlling based on controlling of the on state and off state. So that means whether you can control the output voltage or output current of the device here. Got it point? So such are, what are the here? First classification, these devices are classified based on the controlling of on state and off state of the device. So the first one is a uncontrolled. Okay, uncontrolled device or uncontrolled switch. Okay, this is a uncontrolled, a first classification. So that is a uncontrolled the device. Okay, or switch here. Okay, this is a both are, it is action as a switch, that's why it is called as a uncontrolled device or uncontrolled switch here. And second one is a, that is a semi controlled device. Okay, this one is the semi controlled the devices here. So what will happen in the semi control, I will tell you. So next one, third one is a fully controlled device. Okay, this is a fully controlled device. So got it point? So what about this uncontrolled device? So in this case, on state and off state of the any switch or any device cannot be controlled. Okay, got it? So this is the uncontrolled, semi-controlled, fully controlled. Bhargav, that's correct. So here what means, what it means uncontrolled means, so that is a, here on state and off state of the device cannot be controlled. Okay, and in case of the semi control means the on state, either on state or off state of the device can be controlled, but not both here. So first one, okay, in this case, okay, for example, so here the this part, okay, here on state, okay, on state, on state and off state of the device cannot be controlled. Okay, this is the can't be controlled. Okay, that is the uncontrolled devices. So what is the example per? Okay, this here. So example is a power diode. Okay, power. So diode is a example for the this uncontrolled devices here. So power diode, in case of the power diode, it cannot be controlled. So on-state on-state voltage cannot be controlled, and also off-state voltage cannot be controlled. So that's why it is a best example for the uncontrolled device. Okay. And next one, semi-controlled device. So what about the semi-controlled device? Okay, here the either on state. Okay, this is a either on state or off state of the device. Okay, this is the off, the state of device. The off state of the device can be controlled. The device can be controlled, but not both. Okay, can be controlled, so but not the both here. So this is a the semi control the device. So what is the example for this case? Example is a, so can you tell me what is the example of the semi-control device? Anybody? Semi-control device. Example for the semi-control device. Do it first. We'll discuss many questions. We have a many question based on this concept. Okay, Prati question మనం discuss చేద్దాం. SCR, very good. Okay, this is the example for the SCR. Okay, on state and off there, either on state, off state of the device can be controlled, but not the both. So in SCR, on state the can be controlled, but off state cannot be controlled here. Okay, SCR and GTO. That's correct. So next, this is a fully controlled. Okay, here fully controlled. GTO is a fully controlled, not the SC. SCR only semi control. So in case of fully control here, this one is a on state and off state of the device. Okay, on state and off state. So both on state and off state of the device, off state, the can be controlled. Okay, this is a fully controlled device here. So that means that we can control turn on process and also turn off process. So that is all are. So that is a the power transistors. What is the example for this one? So it is a power transistor here. So and also, so one more. So GTO also is a fully controlled device. Got it point? So all of you clear my point? On state and off state of the device that can be controlled. The three, uncontrolled, semi-controlled and also fully controlled. Divya given SCR, Bhargav SCR given, and also here GTO is not correct. GTO is a fully controlled device. Power transistor means all the transistors, that is a BJT, okay, MOSFET and also IGBT. Okay, all are fully controlled. So in addition to this and another one, so that is a power transistor and GTO also fully controlled. So here example for the semi control is a SCR. Example for the this is a uncontrolled is a power diode, and example for the fully controlled devices is a the G2. Very good. Okay, this is the classification one based on the controlling of on state and off state of the device. Off state, that we can classify it as uncontrolled, semi controlled, and fully controlled. Okay, So next classification, so see here, so classification 2, any classification 2 here. Okay, so this is the another classification. Devices are same. Okay, only 7 devices are there in the power semiconductor device. But another classification based on, okay, based on blocking of voltage polarities. Okay, this is the based on blocking of voltage polarities during during turn off state or during the off state. During the off state. Okay, so whether you can polarity the based on the blocking of voltage polarities during the off state of the device. Okay, this is a off state of device. So how do we classify it? The first classification. Okay, so anybody, the based on the blocking of voltage polarities during the turn off, so that is the first one is a the unipolar device. Okay, this is the unipolar, the device or switch. Okay, like the unipolar switch or unipolar devices here. And second one is a the bipolar. Okay, it is a bipolar, the device or bipolar switch here. So what is the mean by unipolar switch, or what is the mean by the bipolar switch here? Unipolar pitch, the unipolar that switch is a, the it blocks the either positive polarity of voltage or negative polarity of the voltage, but not both. Now similarly, in case of the bipolar device, it blocks both positive polarity of voltages and negative polarity of the voltage. Okay, got it, man? Very good, Nageshwar. So what about this unipolar means? So it blocks, okay, positive polarity of the voltage. Okay, it the positive positive polarity of voltage, the voltage, and negative polarity of, sorry, the here it blocks either positive polarity of voltage, and the negative polarity of the voltage. Okay, this is the either positive polarity of voltage or the negative polarity of voltages. Okay, but not both. Okay, this type of the classification is known as a unipolar switch. Now what is the example for this case? Unipolar switch, it's not bipolar, Nageshwar, it is a unipolar bipolar. Bi means two. Okay, what is the example? Anybody? Unipolar and bipolar switch. Anybody? What is the example? Okay, Isha. That is the it blocks. That is a this is one is a unipolar switches means it blocks. So this one is a which one? BZT. Okay. So all the transistors. Okay, that is a BZT. Okay, MOSFET, and also IGBT also the unipolar switch. Okay, and next one SCR, and it is a diode. Power diode is also unipolar switch. And next, the what about the bipolar switch? The it blocks the both. Okay, it blocks both positive polarity of voltage, positive and negative polarity of voltages here. So now what about the example per positive polarity of the voltage and both cases? So that is the SCR, okay, GTO and also triarc. Okay, this is a the unipolar the and bipolar switch. Okay. So this is the second classification based on the blocking of voltage polarities during off state. This point is a very important. So this one is a during the off state only. Okay, during the off state. So here it can blocks the positive voltage. Suppose if you take SCR, so if SCR is suppose the positive supply is given, so without gate pulses, it can't be conduct. So that it act as a open switch means it blocks the positive voltage. If the negative voltage is given to the SCR, then what will happen? It cannot be conduct. So it blocks the positive voltage as well as a negative voltage. Okay. Yes. Isha, that's correct. Triac is also bipolar. Very good. Okay. Is that clear, everyone? Okay. So next classification 3. How do we classify any other classification? So that these power semiconductor devices are classified based on the current direction. Okay, in on state of the device. So such as, so that is it based on current direction, current direction during on state, during on state of the device. Okay, so what are the during on state of the device? One is the unidirectional. Okay, first one is a the unidirectional device. Okay, it is a unidirectional device. Okay, and second one unidirectional device, and second one is a bidirectional device. Okay, bidirectional device. Got it? My point, what is the meaning by unidirectional? It allows the current only one direction. Okay, here, so this is the unidirectional means the it allows, okay, current, but it allows current in only one direction. So what is the example for this case? So only one direction of the current. It allows the current only one direction. Okay, power diode, SCR, okay, all are unidirectional. Okay, power diode, okay, SCR, okay, next one, GTO, okay, these are unidirectional, and also transistors, power transistors, also unidirectional. Okay, all are power transistor, MOSFET, BJT, and IGBT. So next one, bidirectional means, okay, it allows current in both directions. Okay, both directions here. So that is a the example for means. So this is a triarc is the best example for the bidirectional device. Okay. So this is the bidirectional device and also the unidirectional device. This is the exactly so based on current direction during on state of the device. Got it? All of you clear? So next, one more classification. Okay, that is a classification 4. Classification 4 year. So this is the year power semiconductor devices are classified based on the current, that is a current carrying capacity, and also are the charging current, the carrier device, the carrier concentration here. So that is the first one. So based on, okay, it is based on the carrier concentration, carrier concentration. So this is also one of the question based on the current carrier concentration. So that is a first one. The one is minority carrier device. Minority, okay, minority carrier, the devices here. Okay, the carrier device. And second one is the majority carrier concentration device. Okay, second one. So that is a majority, okay, carrier concentration device, carrier device or switch. Okay, switch here. Very good. Majority carrier device and also minority carrier device. So this one is the best example for the minority, yeah, majority carrier device. So that is a only MOSFET is the example. MOSFET. Okay, this is the example for the majority carrier. And minority carriers here remaining all BZT, SCR, all. So that is the BZT, SCR, okay, SCR, the diode, all are minority carrier device. So what is the meaning of majority carrier concentration and also minority carrier concentration here? So that means the charging, okay, here charging is carrier. So that is a charge is carrying, okay, charge is the carrying, in this case carrying through majority carrier concentration. Okay, this is the through majority carrier concentrations. Okay, that is the exact meaning of, so is a majority carrier. So here the this is a charge is carrying through minority carrier concentration. So actually in this case, so this the B, so suppose if we take the BJT, so it is a this is the in reverse direction or in reverse bias. Okay, reverse bias. So then what will happen here? The charge is carrying, okay, this is the charge is the carrying through, okay, this is the through the minority carriers, okay, minority carrier concentration here, carrier concentration. That's why it is called as a major minority concentration and also majority concentration. So here in case of the match, the here MOSFET charge is carrying through majority carrier. So this is a, we know that power semiconductor device here, this is a two type. One is the P type material and also N type materials here. So here majority here in the P types the holes, okay, majority E, so majority, and this is the N type is the electrons here. So this is based on the doping, okay, doping, adding of the impurities here. So now in this case, in case of the MOSFET, the charge is carrying through majority carrier concentration. That is the whole concentration here. Next one in BZT in the reverse bias, the charge is carrying through minority carrier concentration. That part we will discuss very detailed in the constructional details of the MOSFET, BJT, SCR and diode here. So here this is in our discussion. What are the classifications of? Okay. First classification is based on the controlling of on state and off state. What is the based on the controlling of on state and off state? It is a classified as uncontrolled device, semi-controlled device, and also fully controlled device. So based on the based on blocking of voltage polarities during off state of the device. So these are classified as two types. One is unipolar device, bipolar device. So another classification based on the current direction during on state of the device, such as unidirectional device and bidirectional device. So next one, based on the carrier concentration. So during that is a minority carrier device and majority carrier device. So example for the minority carriers is a SCR, BJT diode, and next one majority carrier device. The IGBT is also the minority carrier device. Okay, that is the IGBT. So majority carrier only MOSFET. Very good. All of you clear now? Everything? Okay. RCT, reverse conducting thyristor. It is used in the firing circuits of the SCR. Reverse conducting thyristor. It is mostly used in the firing circuits of the SCR. Here BJT here, that is a based on the blocking of the voltage. Okay, based on the blocking, but here blocking of the voltage, it is a unipolar. But in the analog electronics, it is actually we know that it is a bipolar device. So that is the based on the carrier concentration. Okay, so that is it can the example per positive side and also negative forward bias and negative bias. It is the analog electronics point of view. That is the amplification point of view. It is a bipolar. But in the switching action point of view, it is a only unipolar. Analog electronics is the only for amplification. Here power electronics is the switching. Okay, here on and off switching action point. So in the switching action point of it is a unipolar device. The unipolar means it is based on the blocking of the voltage during the turn up, during the off state of the device. No, no, no. Actually, in the reverse bias, here BJT is a minority carrier device because of the in the reverse bias charge is carrying through minority carrier concentration. So that is called as a leakage current. Bhargav, మీరు అనలాగ్ ఎలక్ట్రానిక్స్ పాయింట్ ఆఫ్ వ్యూ ఆంప్లిఫికేషన్ పాయింట్ ఆఫ్ వ్యూ it is a major here bipolar device only. Okay, but switching action point of view BJT blocks the positive polarity of the voltage but not negative polarity of the voltage. So that is a unipolar device. Okay, got it? Don't confuse. Analog electronic is only for amplification. Power electronics is the high power applications for the switching actions. Rajans, are we clear now? Okay. So now we will discuss about ideal VI characteristics of the power semiconductor device. So sometimes we have a questions like some diagram is given and how do we draw the ideal VI characteristics. So we will discuss very clear about the practical VI characteristics. So already we know that power semiconductor device is a classified as first one is the here power diode, okay, and second one is a SCR, and third one is the GTO gate turn off thyristor, and fourth one is the triac, and the fifth one is a the power the transistor or power BJT, and the power MOSFET, okay, MOSFET, and the seventh one is a power power IGBT here. So how do we draw the ideal VI characteristics of the diode? How do we draw the ideal VI characteristics of SCR? Similarly, the GTO, triac, power BJT, power MOSFET, and also power IGBT here. Okay, got it in point? So next one, first let us draw. power diode point of view. Okay, power diode. Okay, see here, all of you. Okay, so let us draw the static VI characteristic, ideal VI characteristics, not the practical case. Practical VI characteristics we'll discuss later. So this is the symbol of the power diode. Okay, it is the A for anode, two terminal device. Okay, it is the anode, and this one is a cathode here. Okay, this is the, and it is exactly the symbol of, okay, symbol of the power diode here. Got it? So now coming to the here, this is the schematic diagram of the power diode. So this is the schematic, okay, the power, the schematic pic of the picture of, so this is a picture of the power diode or diagram. So what about this one? Exactly it is a real, okay, real, so practical, okay, power diode, the power diode diagram. So power, the diode practical case, okay, it is not diagram point of view, so real power diode. So this is the anode of the power diode, okay, here power diode, and this is a cathode of the power diode here, okay, anode and cathode power diode. All of again, so it has a two terminals such as anode and cathode. So this is the schematic picture. So it is a anode, okay, anode here, and this one is a cathode. The similarly here is a, this part is a anode and this part is a cathode terminals here. So how do we draw VI characteristics here? So we know that if here this is the anode is a positive with respect to the cathode, so then what will happen? So first one, the first point I am writing here. So when anode is a positive, so that is a when, so VAK, okay, anode to the cathode voltage. So VAK is greater than the zero, okay, greater than the zero. Ideal cases. So when EAK is a good, that means anode is a positive with respect to the negative. So VAK is a negative, or first let us take. So VAK is a the less than the zero, okay, less than zero. So what it means here, negative voltage, okay, negative voltage is given. So anode is a negative with respect to the cathode. So what will happen here? This switch here, diode, the act as open switch. Okay, this is the act as open switch. The so no current. Okay, here. So here the it act as an open switch. So no current flows. Okay, that the no current flows through the switch here. Okay, got it fine. No current the flows through the switch, the flows so through device, okay, the flows through the devices here. So what it means, okay, it means that, so that is a, it blocks the negative polarity of the voltage. Okay, this one is nothing but it blocks the negative, okay, polarity of voltage, the negative polarity of the voltage here. Got it fine? So it blocks the negative polarity of the voltage. So how do we write negative polarity of the voltage? Means, so suppose this part, okay, here, okay, this is a negative polarity of the voltage. It blocks some amount of the negative polarity of the voltage. So this is the exactly ideal characteristics. Okay, here, ideal characteristic. And next one, when VAK is a here, this is the VAK, the is greater than, okay, this is the when anode the voltage VAK means anode to the cathode voltage. So now this is a the greater than the zero. So it means that, so that is the positive voltage. So that is a positive voltage here. So that is a anode is a positive, or anode is a more positive with respect to the cathode. Then what will happen? Diode act as a closed switch. So this is the diode, the act as the closed switch. Okay, closed the switch, so that, yeah, so that the current, so that it allows the current, Okay, it allows the current. Okay, what it means? So that means it allows the current from the anode to the cathode terminals. Okay, anode to the cathode. So it means that, okay, that means the it allows the positive current. Okay, it is allows the positive amount of the current here. So this is the positive, the current of the device. Got it, fine? Can I repeat? See, when this is the anode terminal, all of you clear point? So it is the anode. Suppose here anode is a positive with respect to the cathode. Okay, with respect to the cathode. So now this switch will become closed. So now it is act as a closed switch, so that current, it allows the current from positive to the negative terminals. So next one, suppose this one is a, it is operated. This is the anode is a negative. So with respect to the cathode terminal, then what will happen here? No current flows. So simply it act as a open switch. Okay, open switch here. So what means here? This is the, this much of voltage can block. So that is a, it blocks the negative polarities. Okay, this is the negative and also this is the positive. So it blocks the negative polarity of voltage. But in case of whenever it is excited with the positive supply, and then what will happen? The, it allows the current from anode to the cathode terminal. So it means that it allows the positive current and it blocks the negative polarity of the voltage. Yes, all of you got it, everyone. So now, how do we write the star here? VI characteristics. So it is a blocks the negative polarity here. This is the voltage positive, voltage negative, current positive, and also current negative. So it blocks the negative polarity of voltage and it allows the positive polarity of the voltage. Okay, this is the positive polarity of voltages here. So these are the ideal VI characteristics of the power diode. Okay, all have got it. So that how do we draw? So this is a, sometimes we have a question: what is the safe operating area of the ideal diode? So this is a safe operating area of the diode. Okay, it is a, sometimes we have a question. So what is the safe operating area of the power diode? So that is the first quadrant. Okay, it is the first quadrant. And next one, so this one is a second quadrant. Okay, second quadrant here. And this is a third quadrant. Okay, and it is a fourth quadrant here. Sometimes we have a question: what is the safe operating area of the power diode? Is it a first quadrant, second quadrant, third quadrant, or fourth quadrant? So what is the answer? Safe operating area of the power diode. Safe operating area of the power diode is a, read fast. Very important. So when VAK is up, that means anode is a more positive with respect to the cathode terminal. Okay, cathode terminal. Then what will happen? So that is a, the here the switch act as a closed, so that current, it allows the current from anode to the cathode. It allows the positive current here. So when here anode is a more negative with respect to the cathode, so this the diode act as an open switch, so no current allows to the device. That means it blocks the negative polarity of the voltage. Okay, it is not first and second quadrant. So quadrant point of view, see, it is a negative voltage and positive current. So this is the negative voltage is a negative. Voltage is a negative. Okay, voltage is negative and current is a positive. Okay, positive. So that it is a possible only in the second quadrant. So it blocks the negative voltage, allows the positive current. It allows, blocks the negative voltage and allows positive current. Okay, all of it clear? So now let us discuss about what are the features of power diode. Very very important for computer exams. What are the features of the power diode? Okay, first one. So now tell me, is it a the uncontrolled switch or the fully controlled switch? It's not allowed means it's not correct. Allowing means here Pavan. Allowing means current allows the voltage across the device, right? Current is passes to the device. మీరు ఎలా అనుకుంటున్నారు? కరెంట్ అనేది అలో అంటున్నారు, వోల్టేజ్ అలో ఉండదు కదా. వోల్టేజ్ ఆల్వేస్ మెజర్డ్ అక్రాస్ ద డివైస్, బట్ కరెంట్ passes to the device. So here it blocks the negative polarity of the supply voltage and allows the positive current. Pavan, okay, all of it clear? Now tell me, is it a uncontrolled switch or fully controlled switch? Yes, got it, Pavan. Here always voltage is measured across the device. Current passes to the device. So diode allows the positive current and blocks the negative voltage. When this device is the excited with the AC supply, that is a positive supply, it allows the current. That means for positive voltage it will be conduct. For negative voltage it won't be conduct. Okay, now tell me what are the features of the power diode. So now it is the first one, it is uncontrolled. Okay, this is the uncontrolled device. Okay, device or switch. Okay, first one, uncontrolled device or the switch here. And now tell me, is it unipolar or bipolar? Unipolar or bipolar? First, second feature, it is a it blocks the only one polarity of the voltage, that is the negative polarity of the voltage. So that's why it is a unipolar. Okay, unipolar device or the switch. Okay, and third one, so it is the unidirectional switch. Okay, it is a unidirectional switch or unidirectional device or unidirectional switch. Okay, next one, any other feature? What is the safe operating area of the device? Safe operating area of the device. Operating Safe operating area. So is it the first quadrant or second quadrant? Safe operating area of the device. Okay, it is a second quadrant. Okay, very good. And next one, the it is okay. The it is a okay. It is minority carrier charge device. Minority minority carrier device or switch. Okay, next one, any other feature? Already we have discussed. Okay, it allows the only positive current. Got it point? So it allows positive current only. Positive current only. Okay, so that it is treated as DC switch. It is also one of the question. What is the meaning by DC switch means? It allows the only positive current but not the negative current. So that it is treated as a DC switch. All of it clear? Allows the positive current and blocks the negative voltage. That's correct. So that's why it is treated as a unipolar. So that is unipolar means, so it blocks the, okay, it blocks negative voltage only. Okay, negative. The unidirectional means it allows positive current. It allows positive current. That's why it is treated as a unidirectional. Okay, these are, sir, if any device have flow of negative current, so it is AC switch. That's correct. Okay, here your question point of view, whether the power diode is a DC switch or AC switch, it is a the DC switch. DC switch. Yes, that's correct, Pawan. Now let us discuss one more device. Very, very important for exams point of view. If you know all this, it's a very easy to answer the questions. Okay, next, second one, silicon control rectifier. Now this is the symbol, okay, for the silicon control rectifier. It is also called SCR or thyristor. So now this is the gate, anode and cathode. So now this one is the terminals, anode, okay, it is a cathode terminal, and also so it is a gate is a GL. Okay, this is the symbol of, okay, symbol of the SCR. Clear mind? So now what about the practical case? Okay, it is the SCR. Okay, here it seems to be like this. Okay, practical SCR. So diagram and symbol here. This terminal is a cathode, anode and also gate. Okay, this is exactly practical SCR. And how do we draw these characteristics? All of it clear? So first tell me. So when gate here, so that is the initially anode is more positive, the anode is a negative with respect to the cathode. Okay, first point. So that is the when the anode, okay, when the anode is negative, okay, anode is a negative, and anode is a negative with respect to the cathode. Okay, cathode here. So what it means here, the voltage, supply voltage is a negative voltage. Okay, supply is a negative voltages here. So what will happen, this SCR act as a open switch. Okay, that is a SCR, the act as open switch. Okay, open switch. So no current, okay, here, so no current flows, the no current flows from anode to, okay, this is the anode to the cathode terminals. Okay, terminals here. So what it means, okay, here SCR, the no current flows, so that's why it blocks positive voltage or negative voltage. So it blocks, okay, it, so that means, so that is the negative voltage. So this, that means that it blocks the negative, the blocks the negative polarity of the voltage. Okay, here negative polarity of voltages here. Okay, this is the first point. So when anode is more negative with respect to the cathode, anode is more negative, or anode is a negative with respect to the cathode. That means the cathode terminal is connected to the positive, and here the anode is connected to the positive terminal, cathode is connected to the negative terminal. So at this condition, this switch is act as a open. So that's why no current flows from anode to the cathode terminals. Ideal case. So that's why. What about the characteristics? So how do we draw these characteristics here? So that is a, it blocks the which voltage. So this one is the positive voltage and this is the negative voltage. So it blocks the negative polarity of the voltage. Okay, it is the blocks the negative polarity of voltages here. So next one, when anode is okay here, the when the anode, okay, this anode, the is the more positive, okay, is more positive the with respect to the, okay, cathode terminals, okay, cathode. So it means that here supplies the positive voltage, okay, positive voltages here. So therefore here the when it is anode is the more positive with respect to the cathode terminal. So what will happen? Current, this is a SCR act as a, okay, yeah, this SCR act as the closed switch, okay, closed switch, so that, okay, so the it allows the current, okay, it, so that current passes, okay, from the current, the passes from the anode to the cathode terminals here. So what it means, okay, here, so the here is a allows the positive current. So only this is possible. So with gate circuit, okay, with the gate circuit here. So otherwise, okay, with gate pulses, suppose gate should be closed. So then only is the current allows. So otherwise it is not allows here. Anode is a more positive with respect to the cathode. SCR is closed switch. So whenever the current passes from anode to the cathode. So this is the with gate pulses. Okay, gate pulses here. So if gate pulses is not given, so therefore it is a what it means here. It allows, okay, this means the it allows positive current. Okay, positive current here. So clear point. So how do we write positive current? So this is a allows the positive current of the voltage, okay, with the gate pulse. Suppose the in the reverse manner. So when anode is a more positive, okay, anode is connected to the positive terminal and cathode is connected to the negative terminal, okay, negative. So but here this is the, but IC is equal to gate current, the is equal to 0. So at this time what will happen? The SCR act as, okay, act as open switch, the open switch here. So that means no current flows. So the no current flows from, current flows from anode to, okay, this is the anode to the cathode terminals here. So what it means here, no current means it blocks, this means, so here it blocks the positive polarity of the voltage, positive the polarity of voltages here, voltage terminals. Got it point? So very important. So it blocks the positive polarity of the voltages here. So now tell me, what is the safe operating area of the device? Okay, this is a the safe operating area of the device. Okay, so this part is a safe operating area of the device. So what is the safe operating area of the SCR? Is a first quadrant and second quadrant. Okay, got it? Okay, all of you clear? Is that clear, everyone? Okay, so now let us discuss what about the features of the SCR. What are the features of SCR? Okay, now tell me, the is it the here uncontrolled or semi-controlled or fully controlled? Pavan, initially here IC is equal to, here when anode is a positive, okay, this is the cathode is a negative, here gate circuit is a open, the here what is what will happen, no current allows from the here, no current flows from the anode to the cathode terminal. Okay, got it? Suppose the in this there are the three variations are there. So first one, okay, see, assume here this is the gate terminal G, and next one anode is a and this one is the cathode is the, it is denoted by the K. So initial case, suppose anode is a negative terminal and cathode is a positive terminal. So that time this switch is act as a open, so that the no current flows from the anode to the cathode terminal. It blocks the negative polarity of the voltage. All of you got it? And next case, okay, another case, suppose, so anode is a, okay, this is the anode terminal is a positive. Okay, here anode is a positive and cathode is connected to the negative terminal. But this gate circuit is the gate pulses IZ current. So this IZ is equal to 0. No gate pulses are given. So that's why here this is it act as a open switch. That means in order to conduct the SCR, some minimum gate current is required. That I will tell you in the practical case. Okay, practical VI characteristics of SCR. So here minimum current is required. So if without any minimum current, it is simply it won't be conduct. Okay, it is act as a open switch. So that's I have A is a positive, K is a negative, and the gate current is equal to 0. SCR act as a open switch. So open switch means it is a simply open circuited. Okay, open circuit. So that what about this voltage across these polarities? So this is anode and cathode. So this is a Vs. So that is the VAK is equal to positive voltage is here. So that means it blocks the positive polarity of the voltage. Okay. And next one, suppose if gate pulses are given. Okay, then it will be conduct from anode to the cathode. Okay. So that's why here it blocks the positive polarity, negative polarity of voltage, and it conducts only one current. That is a positive current only. Okay, all of it clear now? Okay, is that clear, everyone? Yes. So now tell me what are the features of the SCR? First, tell me, is it a uncontrolled, semi-controlled, and fully controlled? Here we are controlling the on state, but we cannot control the off state. So that is the in SCR. Okay, in SCR. So SCR, the on state can be controlled. On state can be controlled, but off state cannot be controlled. Off state cannot be can't be controlled. Okay, so that so the it is treated as is treated as semi controlled switch. Control switch here. Got it fine? So next one, the is it the unipolar or bipolar switch? Okay, is it a unipolar or bipolar switch? It is bipolar switch. Why? Because it blocks the positive voltage. It is the bipolar switch. So it blocks the positive voltage and negative voltage. And what about the direction of the current? Okay, it allows the only positive current. So that's why it is a unidirectional switch. Unidirectional the switch here. Got it? So very important the per questions point of view. So next one, what about the here? Is it the minority carrier concentration device or majority carrier concentration device? So it is the minority. Okay, minority concentrate the carrier concentration device. Carrier device. Okay, And next one, so it allows the positive current only. Okay, it allows positive current only. Okay, so that, so the it is treated as, tell me, the it is treated as AC switch or DC switch. The it is treated as the DC switch only. Okay, yeah, it allows the positive current only, but not the negative current. So that's why it is treated as a DC switch. And next one, what is the safe operating area? The safe operating area of the device. That is the first and the second quadrant. Okay, second quadrant. So that is a safe operating area of the SCR. Very good. Okay, DC switch. SCR is also DC switch. First and second quadrant. Very good. And next one, let us discuss one more device. The gate turn off thyristor. These are the symbols, different type of the symbol C. So we can represent here positive gate and negative gate. And these are the two directions. This is also positive gate and negative gate. So it is a similar to, okay, it is a similar to, so this one is a, it is the similar to SCR only, similar to SCR. The except negative gate pulse or negative gate current here. So it is similar to SCR except gate pulses here. So these are the different type of the symbols, okay, of the symbols of the SCR, or the this is the gate turn off thyristor. So this is the practical case. Okay, it seems to be like practical the GTO. Okay, it is the exactly practical diagram. Anode, gate and cathode here. Got it? And how do we draw the gate VI characteristics? Suppose initially, listen, all of you listen. Okay, this is the one point I have taken. So suppose here anode is a negative. Okay, anode is negative. See, anode is a negative, and cathode is a positive. This anode is negative and cathode is a positive. So what will happen? So this is a, so it is a, this switch is yeah, anode is a negative and cathode is a positive. This gate is not connected. So that is a eyes. The gate is not connected here. So then what will happen? This switch is a, the seems to be like open circuited here. So first case here I am taking. So that is anode is a negative. Okay, if anode, the anode terminal is connected to the negative polarity, okay, negative the polarity here, and cathode terminal is connected to, okay, this the cathode is connected to the positive polarity here. So that time this switch is a act as a open switch, okay, open switch here, so that here no current allows. So open switch, so the no current flows from the anode to the cathode terminal, the anode to cathode. So here flows from, it is this is the here minus Vs, right? Suppose what is the voltage across this device? So this is equal to Vs is equal to minus Vs. So it means that it blocks the negative polarity of the voltage. So that means here, that means that it blocks, okay, in this case. So here open the switch, and it means that, okay, it blocks the negative polarity of the voltage, negative polarity of, okay, got it, point, negative polarity of the voltages here. And next one, in the second case, suppose if anode is a positive terminal, okay, positive, okay, this gate is not connected here, this is a positive, and a cathode is also negative, and here gate is not connected. Then what will happen here? It is also the here act as a open switch. So no current here. That means it blocks the positive polarity of the voltage as well as the negative polarity of the voltages here. So this is a positive polarity and also negative polarity here. And next one, Suppose here anode is a positive and cathode is a negative, okay, and it is connected. The gate is a connected here. Gate current IC. So here IC not equal to IC is equal to 0. Okay, here IC is a greater than the 0. So then what will happen? It is act as a closed switch here. So this is the exact diagram. So three cases. So it is a open switch, and so when it is excited with the negative voltage, that is the anode is a more negative with respect to the cathode. It acts as an open switch so that no current allows the from anode to the cathode terminal. So here anode is a more positive with respect to the cathode, but gate current is not connected. So therefore it acts as an open switch. Okay, so that here it allows it blocks the positive polarity of the voltage. When gate current is given, so it allows the current from anode to the cathode terminal. So this type of voltage, there is nothing but, so it allows the positive current and blocks the negative voltage and positive voltage. And one more here, see it control. Okay, this is in our hand. We can control the on state, but we can here control the on state. And also if you remove the gate pulses, okay, negative gate pulses is there. If you apply, we can turn off the SCR also. You can control the on state and off state. That's why it is treated as a fully controlled, and it's also called self-commutating device. Why it is a self-commutating? Commutating is nothing but the process of turning off the device is known as a commutator. So now if the negative gate pulses is given to the gate GTO, the device will become turn off. That's why it is called as a self-commutating device. Okay. So what will happen? So here, so when the VAK, so is positive, VAK is a positive, and the gate current is equal to 0. So then that is it act as open switch, so that no current. So here, so the no current flows from anode to the cathode terminal. So what it means here? It means it blocks the positive. So it means blocks positive voltages here. Got it? So next third case. So third one. So when BAK, okay, is the EAK is a positive and gate current is the greater than the 0. So current flows from anode to the cathode terminals. Okay, so what it means here? It means that it allows positive current. Okay, this is the diagram point of view. That it blocks the positive voltage and blocks the negative voltage, and also it allows the positive amount of the current. So here to turn on, okay, in this case, to turn on positive gate pulse, okay, are given. So to turn off negative gate pulse. Pawan, yes, Divya, that's correct. In SCR, there is no there is here. We cannot turn off by using the gate. In SCR, gate loses its control once it's turned on. In SCR, can't turn off by gate pulse, but in GTO we can. That's correct. That's why it is called as a self-commutating device. That's why it is called as a self-commutating device. Okay, got it, everyone? Is it clear? So now the question point of view. So what are the features of the GTO? Features of GTO, gate turn off thyristor. So now first one, tell me, is it semi-control? Pawan, your question is, what's your question? Sir, gate pulse is provided with the positive and negative pulse. I mentioned here that to turn on the device, positive gate pulse should be provided, and to turn off the device, negative gate pulse should be provided. Okay, Pavan, are you clear now? To turn on, okay, to turn on the positive gate pulses, okay, to turn off negative gate pulses. Okay, now tell me, what is the first feature? Is it a cell with the uncontrolled, semi-control, or the fully controlled? Okay, it is. Okay, it is fully controlled device. Fully controlled device. Got it point? And next feature. So it is a unidirectional or unipolar. Unidirectional or the unipolar or bipolar. It blocks the both positive polarity voltage and negative polarity voltage, so that it is treated as a the bipolar device. Bipolar device is here. So now here the fully control means on state and off state both can be controlled. On state, so both on state and off state, okay, can be controlled. Can be controlled. That's why it is a fully controlled. On state can be controlled by using positive gate pulse. Okay, positive gate. So by positive gate, and off state can be controlled. Okay, by negative gate. Okay, this is a, so this can be by negative gate. Okay, negative gate pulses here. So that's why it is treated as a fully controlled device. Okay, and next one. So is it a unidirectional or the bidirectional? It allows the current only one direction. That's why it is a unidirectional the switch or unidirectional device. Okay, devices here. So next one, so it is a self-commutating device. That means by applying the, so it is the self, okay, self, the commutating device. Commutation means turning off. Commutating the device. Okay, what is the reason? So it allow, here they say it can be turn off itself. So it can be turn off, okay, itself by negative gate pulse. Negative gate pulse. That's why it is called as a self-commutating device. And the fifth one. So now tell me, is it the minority carrier concentration device or majority carrier concentration device? Yes, Pavan, that's correct. Difference in the only SCR and GTO. In SCR, by using the gate pulses, we cannot turn off. But in the GTO, we can turn off. And now this one is a minority carrier concentration device. Concentration device. Okay, it is minority carrier concentration device. And sixth one, what about the safe operating area? Now tell me, is it a AC switch or DC switch? Here it allows, okay, it allows positive current only. Positive current only. So that the it is treated as, okay, treated as the DC switch only. DC switch. Okay. And next one, what about the safe operating area? Okay, safe operating area. Is it a first quadrant? That is a quadrant. The and first quadrant and second quadrant. So these are the questions based on this concept. So it is a fully controlled, bipolar, unidirectional, self-commutating minority carrier. It allows the positive current only, so that it is treated as a DC switch. And what is the safe operating area of the device? It is a first and second quadrant. Okay, is that clear, everyone? Very good, Bhargav. Very, very important. Okay, all the questions in the IES gate comes from these features only. We know very well we can answer any question based on this concept. ఈ క్వశ్చన్స్ అన్ని ఫీచర్సే, క్వశ్చన్స్ అనే ఫీచర్స్ అని చెప్తున్నాను కదా, అవన్నీ క్వశ్చన్స్. No, not like that. Thyristor, any switch can be used for DC supply and AC supply. The DC switch means that it allows the only positive current. AC switch means it allows the positive current and negative current, not the using purpose. Pavan, DC switch meaning is only for DC, not like that. It's not like that. The any device can be used for AC supply and also DC supply, but this allows the positive current, okay, and negative current. It cannot be allows the negative amount of the current. That is the meaning of DC switch and AC switch. Okay, next, triac. So these are the symbols for the real-time symbols for the triac. See here, all of you. So these are the exactly the triac diagrams. Okay, it can be available like this also. Triac anode 1, anode 2, anode 1 and anode 2, anode 1 and anode 2. So sometimes this terminal is a MT1, terminal 1, and it is a MT2, okay, terminal 2, and this one is a gate. These are the symbol, okay, symbol for the triac. So triac in the sense exactly anti-parallel connection of, okay, the anti-parallel connection of the two SCRs, okay, anti-parallel connection of the two SCRs. So that is the meaning of the triac, okay. The two SCRs are connected in anti-parallel. So this is the exactly diagram. All of it clear now? So these are the practical diagrams, practical pictures of the triac. Minority and majority carrier concentration I will explain very clear in the constructional details. Okay, why it is a minority, majority? So that part we will discuss in the constructional details. Okay, Pavan. So minority carrier concentration means in the reverse bias, okay, reverse bias, very small amount of the current passes through the device, okay, due to minority carrier concentration. So that is called as a minority. So majority carrier concentration means in reverse bias, the charging is carrying through majority carrier concentration of the device. That part I will tell you very clear in the constructional details. These are only ideal cases, ideal VI characteristics. Okay, Pawan? Right. So now tell me here, what about these characteristics? Okay, there are the 4 cases. See, so all of you see here. First case 1. Okay, when MT1, suppose this is treated as a MT1 and MT2. So now here MT1 okay, mt1 is greater than the mt2, okay, mt2 here. So that is nothing but here more mt1 is more positive than the mt2, so that is the positive voltage, okay, positive voltage is here. So then what here positive voltage, and Ic here not equal to Ic equal to 0, okay, Ic is the equal to 0. So then what will happen here, this is a triarc. So at this condition, the triarc act as a, okay, this is the mt1 the greater than mt2, triarc act as here this is a open switch, okay, open switch, so that the open switch, so no current, okay, here, so no current flows from, okay, flows from mt1 to, okay, terminal 1 to, so these are mt1 to mt2 terminals, okay, mt2 terminal. So what it means here, that means that it blocks the positive polarity of the voltage, the it blocks positive polarity of voltage, polarity of the voltages here. So got it fine. So how do we write positive polarity? So this is a positive voltage and negative voltage. So it blocks the positive polarity of the voltage. Got it fine? So all of it clear now? When MT1, anode 1 is more positive as compared to the anode terminal, anode 2 terminal, and gate current is equal to 0. So then what will happen? It triarc act as a open switch. No current flows from MT1 to MT2. So that it blocks the positive polarity of the voltage. Okay, got it? So next one. The similarly, okay, here second case. Okay, that is a, when MT1 is a greater than, okay, terminal 1 is a greater than the MT2. Okay, MT2. So that is nothing but it is a positive voltage only. We are applying positive voltage to the device. So but here this IC gate current is greater than the 0. Okay, gate current. So gate pulses are given. Okay, gate current. So then what will happen here? So this triarc. Okay, here triarc. So this is a act as, okay, now this one is a, the triarc act as a closed switch. Triarc act as the closed switch. Okay, cutting point. This is the triarc act as a closed switch. So current allows from anode to the cathode terminals. Okay, this is it. Triarc allows from the closed switch. So here this is it. The triarc allows the closed switch here. So current flows from, current the flows from anode, this is a empty the 1 2, okay, empty 2 here. So that means it allows the positive current, okay, it allows the positive amount of the current here. So how do we write in this case? This is a positive current and this is a positive one. So now it allows the positive current, okay, positive current. So this is the positive voltage and one. So next one in the another case, see, and when mt2 greater than, okay, this is the when third case, the when mt2 second terminal the is greater than the mt1, okay, but Ic is equal to, but okay, Ic is equal to 0. So then what will happen here, there is no gate pulses, okay, we are gate pulses. So now it means that here it is a more positive, that means here two the SCRs are there. So now triarc act as a, okay, act the as open switch. Okay, this is a open switch. So here no current flows from, no current the flows the from the eight, which terminal here, from the second terminal to the from the terminal 1. So that it blocks the, okay, it blocks which voltage, this is the negative amount of the voltage. So it blocks the negative voltage, okay, negative voltage. So now this is a mt1, otherwise you can write it blocks the negative voltage. So this part also we can write. So MT2 less than the MT, okay, MT2 less than here. So now it is a less than, so then what will happen? MT1 less than the MT2. So now but IC is equal to 0. That is a negative voltage. Triac act as a open switch, no current flows from here. So now it block. So now similarly fourth one. So when MT1 is a terminal 1 is a less than the MT2. So that IC is not equal to 0. Okay, then what will happen? So it allows the positive current. So this is a, it allows the negative current. So allows the negative current of the device. So that's why we can conclude here. So this is a positive voltage and blocks the negative voltage. At the same time, the allows the negative voltages here. So what about the safe operating area here? This safe operating area of the device. So this is a four quadrant. Okay, this is complete. The is known as a safe operating area of the triac. So sometimes we have a question: the which device is the best possible for four quadrant operation of the choppers? So that is the triac. Okay. Yes. Here you can take MT1 means I have taken is a MT1 and MT2. All quadrants. That's correct. So that what are the features here? The features of the triac. Tell me first one. The features. Okay, first one. Is it here uncontrolled or fully controlled or semi controlled? We can control all. Which one? That is the first one is it is a fully controlled device or fully controlled switch. Control switch. And now tell me, is it a bipolar or unipolar? Okay, it is a bipolar. It blocks the positive voltage and also negative voltage. So now this one, it blocks the positive voltage and negative voltage. That is, it is the bipolar switch. Okay, bipolar switch. Bipolar switch. And next one, third one, the it is the unidirectional or bidirectional. It is bipolar switch and it is a bidirectional, bidirectional, bidirectional switch. And now fourth one, safe operating area here. It is the all quadrants. Okay, this is the all four quadrants. All quadrant. Okay, all. That is a first, the second, third, and fourth quadrant. So that is the safe operating area. Very good. And next fifth one, is it a minority carrier concentration or majority carrier concentration? So it is a minority that the charge is carrying through minority carrier concentration. So that is a charge in the reverse bias. Charge is carrying through, okay, minority carrier concentration. Minority carrier concentration. Carrier concentration in the reverse bias, so that it is treated as a minority carrier device. And sixth one, is it a AC switch or a DC switch? Okay, it allows positive current and negative current. Negative current. So it is treated as a, it is treated as which switch here? It is treated as AC switch. All of you got it? So very very important point. So here thyristor is a DC switch. Okay, diode is also DC switch. But triac is a, it allows positive current as well as a negative current. So this is a, that's why it is treated as AC switch. Very good. So these are features of the triac. Okay, very very important. Features of triac. Okay, very good. All of it clear? Is that clear, everyone? Okay, next power BZD. Already we know this. The in the analog electronics we studied about these things, but here switching point of view we will discuss. So is it a unipolar switch or the bipolar switch? Switch point of view, it is a bipole. That is a switching is a the unipolar switch. The device point of it is a bipolar device. Switching point of it is a only the unipolar switch. I will tell you that part. So what are the terminals here? So this is the base, the collector and here. So that is the symbol for this diode. So which has a three terminals. Okay, three terminals. So such as the base, three terminals are there. So one is the base, okay, and second one is the base. It is denoted by B, and the collector. So it is denoted by the C, and one more emitter. Okay, this is the denoted by the E here. So these are the three terminal the devices here. So in the circuit point of view, here this is the input circuit and output circuit. So now this is the VBB. Okay, here the VB here VBB, and this one is a RB. Okay, and it is a RC, and the voltage is a VCC, and current passes through from this supply output circuit. So now this one is a IC amount of the current, and this current is a IB current here. Got it point? So now what about this voltage? Okay, this voltage is a VCE here, the collector to emitter voltage. So this is the base, and this point it is a the here this is the collector, and this is the emitter, and this point is the base here. So that's why it is a VCE, and this one is a collector to emitter voltage. So now it is a by KVL equation. Okay, in this loop. So here in output loop. Okay, in the output the loop. So now here, so by KVL equation. So how do we write the here equation, KVL equation here? So this KVL equation is equal to, so we can write the KVL equation, apply the KVL equation. The VCC is equal to, that is the ICRC plus the VCE here. So how do we write this collector current? So this collector current IC is equal to, that is the VCC minus VCE, the divided by RC values here. So if IC is equal to 0, okay, this one is a, the if the IC here VCE is equal to 0, okay, EC is equal to 0, so then IC will become, okay, this, okay, it is equal to IC equal to the VCC divided by RC values here. Now similarly, if VCE is equal to some the VCC value, okay, this VCE equal to some VCC value. So this ECE can be controlled by this current, the base current here. So now this is a, so then the this value IC the is equal to how much, this value IC VC is equal to VCC. So this is equal to 0 amount of the current. So where ECE can be controlled, ECE the can be controlled, okay, can be controlled. So by the which current? By the base current IB values here. So all of you clear point? So one point is a here, okay, this is the, when this axis we can take the VCE, X is a VCE here, and the y-axis is a IC current. Okay, IC current. So when VC is equal to 0, okay, when EC is equal to 0, so then what about this current? Okay, when EC is equal to 0, IC is equal to VCC by RC. So now this is a 1 point. Okay, this is the 1 point here. So now it is equal to 0 the VCC divided by the RC values. Okay, RC value, this is the point. So from this point, got it? And similarly, so when VC is equal to VCC, then what will happen here? When VCC is equal to VCC, so this value is a, okay, this is the 0, okay, here first one, VCC is equal to VCC, so this is the VCC comma 0, IC is equal to 0 values here. So now combine these two here, so this is the same operating area of the power BJT here. But here we have the IB current. VCE can be controlled IB. Suppose for mean low value of the IB, okay, we are applying very low value of the IB. So IB current is a low. So this is a IB is, okay, the low value here. IB is a low. So suppose IB is a high value. So then what will happen? So this is the exactly the current values here. So this is this is for the IB is a I value of the IB values here. So when here this is the exactly, so we have taken three reasons here. So this is called as a cutoff reasons. Okay, cutoff reason, and this reason is known as a saturation reason. So now this is called as the saturation reason, and this one is a other. So therefore what we conclude here, so this reason is known as the saturation, okay, saturation reason, okay, this reason is known as a the cutoff reason, okay, cut off reason here, and in between these, okay, this is called as a the active reason here. So this active reason only for amplification purpose. So suppose here, so when the here when SCR here, when the BJT is operated in the cutoff region, so now when the BJT in cutoff region, when the BJT the in cutoff region, okay, cut off the region, then what will happen? So cutoff region, it act as a, okay, act as a the closed switch, sorry, it act as the open switch here, open the switch. So therefore it doesn't allow the current from the collector to the emitter. So that means it blocks the positive of the voltage. So when suppose when the BJT is operated in the saturation, okay, saturation region, so then so this is act as a the closed switch. So that means the it allows the positive current, okay, positive current, and in this region, so it blocks the positive voltage, okay, positive voltages here. So all of you getting point? So when BJT is operated in the cutoff region, it allows the current from the collector to emitter. The when BJT is operated in the saturation region, so it blocks the positive sorry, when it is operated in the saturation region, it allows the current from the collector to the emitter. And when BJT is operated in the cutoff region, it is act as an open switch, so that no current allows from the collector to emitter. So it means that positive polarity, it blocks the positive polarity and it allows the positive current. So that's why safe operating area is the first quadrant only. Okay. All of you got it? Everyone? Okay, clear? Everyone? Is that clear? So what we conclude here? What are the conclusions? This is the, that means significance of the saturation is a closed switch. Okay, suppose in analog always device should be operated in the active. So this is the only in analog electronics. But in the power electronics, device should be operated in the cutoff region or saturation region. When it is operated in the cutoff region, this device is act as a open switch. When it is operated in the saturation region, it is act as a closed switch. Suppose if it is operated in the active region, that is a amplification purpose. So that is not in the power electronics. So this part completely here analog electronics part. All of you got it point? The power BJT, what is the here? Always analog electronics, the BJT is operated in the active region. But in the power electronics, the requirement is switching action. So when whenever BJT is operated in the cutoff region, the here it acts as a open switch, no current allows from the collector to the emitter. So that means it blocks the positive polarity of the voltage. When this BJT is operated in the saturation region, so it allows the current from the positive the collector to the emitter. So what it means here, it allows the positive current. All of it clear, everyone? So now tell me, what are the features of the BJT, right? Here, features of BJT. The exam point of view, these are very important. So BJT features. Okay. Now tell me, is it a fully controlled or semi-controlled or uncontrolled? So here we can control on state and off state by using the which current? The base current here. So that's why. So it is a fully controlled. Okay, it is the fully control switch. Control switch here. Got it? And second one, it is unipolar or bipolar switch. Okay, it is unipolar switch. Unipolar switching. I'm not talking about the device. BJT is a bipolar device, but switching is a unipolar. Okay, BJT is a bipolar device only, but switching point of view, it is a only unipolar switch. Okay. Next, third one. Now, is it tell me it is a unidirectional or bidirectional? So it is a unidirectional switch. Directional switch. Okay, got it? And fourth one, what is the safe operating area? Safe operating area is first quadrant. Okay, it is a first quadrant. Safe operating area is a first quadrant. Clear? Now tell me, is it a DC switch or AC switch? Okay, it is DC switch. Why? Because DC switch only. Because it allows the positive current only. Because it allows positive current only. Okay. So next one. So another question, and it is a minority carrier concentration or majority carrier concentration. Okay, it is a minority carrier concentration device. Okay, got it. And next one, it is a current control. So here on state and off state can be controlled by the base current. So here on state of the switch and off state, okay, off state can be controlled by base current. So it is treated as current control device. Control device. Got it? Very, very important. Okay, all of it clear now? Okay, is that clear, everyone? Okay. So now answer this point. Let us discuss about power MOSFET. Power MOSFET. Okay. So this is the symbol for the power MOSFET. Okay, symbol of the power MOSFET. And what are the terminals here? So one is a gate terminal and also D for the drain. Okay, gate and drain terminal. S for the source. The gate, the drain and source. So what are the terminal? So it has the three terminals. Okay, three terminal as like the BJT only. Okay, got it point? So this is it has a 310. So what about this voltage? Okay, here VG. Okay, this is the gate terminal. Okay, gate. And this one is a drain terminal as like a symbol. So drain, and this is the source terminals. Okay, here source. And this one is a the VC. Okay, VZZ or VGS. Okay, VZZ. And what about this voltage? Okay, this is the RG. Okay, and this voltage is a BGS. Okay, BGS. And this is equal to this voltage is a VDS, and here VDS, and this voltage is the VDD, and current is a RD current. Okay, this control the current one. So current passes here, resistance is the RD, and current is a current passes through from drain to the source. So that current is a ID current here. So where ID in the sense current passes from drain to the source. So just apply the KVL in this loop here. So therefore by KVL equation, KVL the equation. So that is a VDD is equal to, so that is a ID RD the plus, okay, VDS. So from which ID current, the drain current is equal to, so VDD, okay, minus, okay, VDS divided by RD values here. Okay, minus A. So if the here, this is the first case. So if VDS is equal to, okay, VDS is equal to 0. So then what will happen? Drain current ID is equal to, so that is a VDD divided by RD values here. So next one, if VDS is equal to, okay, VDS is equal to, so VDD values. So then, so this drain current ID is equal to 0 here. So where here, so this is the VDS, okay, where the VDS that can be controlled by, okay, can be the controlled by, okay, this is a control. So by the VGS, okay, VGS here. So that's why it is called as a voltage controlled device. So the BJT is a current control device. So now first point, let us take, where is the first point? So if VDS, let us take x-axis is a VDS, and current is a, this is a positive current, and next current is a ID amount of the current. So now let's see the first point. Okay, this is a VDS. Okay, that is a VDS is equal to 0. ID is equal to VDD by. So this is a 0 divided by VD. Okay, VDD by RD values here. This is the first point. And is a next one. When VDS is equal to VDD, and this one is a that 0. Okay, that is equal to VDD the comma 0 coordinates here. So compare these two here. So this is a, so same operating area of the MOSFET. So per low value of the VGS, okay, low value of, so this is the curve for the, when the VGS is the low, so this is per low value, okay, here low value of VGS. Are you clear point? So now this one is, so here the VGS is a low, okay, low value of VGS, and here VGS is a high value. Then what will happen? So now this is a exactly curve. So this is for VGS high values here. So compare these two, divide the regions. So first region, okay, this is a cutoff region, okay, cutoff. And next one, this one is the saturation region. Okay, this is the called the saturation region. Okay, saturation region and cut off regions here. So it is a similarly cut off region. Okay, cut off region. And what about this region? Okay, this one is the saturation region. So what we conclude here? So when power MOSFET is in the cutoff region, it acts as a open switch so that no current passes from drain to the source. When power MOSFET is operated in the in the saturation region, it allows the current from the drain to the source. So what it means here? So there is a when MOSFET, okay, this is the MOSFET, the in cutoff region, okay, cutoff region, so it act as open switch, okay, open switch here, so that it blocks the which voltage here, blocks the positive, blocks the so negative voltage, okay, blocks the sorry, it blocks the positive voltages here. So next one, and next year this is a when MOSFET is in the saturation region, okay, then what will happen? So this is a act as a closed switch. So when it is a closed switch, it allows the positive amount of the current. So when it is the positive amount of the current means it allows the positive voltage and also it allows the positive current and blocks the positive voltage, so that safe operating area is a first quadrant. Okay, got it? All of it clear? Okay, so this is about power MOSFET. So now what are the features of power MOSFET? Tell me. Features. So now tell me, is it a fully controlled? Here, fully controlled or semi-controlled or uncontrolled? So first one, it is fully controlled. Fully controlled switch. Fully controlled switch here. Why? Because here on state and off state. So because on state and off state can be controlled by which voltage? The controlled by the VGS, drain to source voltage. That's why it is a fully controlled device. And next one, it is a unipolar or bipolar switch. Tell me. It is a unipolar. Okay, it allows the only positive voltage. Sorry, it allows the positive current. It blocks the positive voltage only. So that is it is a unipolar switch. And next one, unipolar switch. And what about the direction? It is a unidirectional switch. What is the reason? So it allows only positive currents. That's why it is the unidirectional switch. And fourth one, what is the safe operating area? So safe operating area is the first quadrant only. First quadrant. Okay. And next one, and it is a DC switch or AC switch. Okay, it allows the positive current. So that's why it is the DC switch only. And sixth one, it is a so majority carrier concentration or minority carrier. This one is a only one device. So that is a majority the carrier concentration. So that means charging in the charging the through majority carrier concentration of the device. So that is the majority carrier concentration. Okay, got it point? Yes, except MOSFET, all are minority carrier device. Very good. So next one more final one, power IGBT. What is the symbol for this power IGBT? So these are the symbol for the power IGBT. So now this one is the gate, okay, and it is a collector, okay, and this one is a emitter here. So this is the exactly the here the combination of the BJT and MOSFET. So gate, collector and emitter. So now this voltage, this terminal is a the first point. Okay, this one is a terminal of the gate, and this terminal is a collector, and this terminal is a emitter here. So this voltage is a we get this is the VGZ, and it is the VCC, and this is the VCE. Okay, voltage VC here. So current passes through your RC, and current is a IC amount of the current. So now just apply the KVL in this loop here. So now this by KVL, okay, KVL equation. So now this current is a, okay, this current. So now here IC current, gate current, okay, gate current here. So now this is the by KVL equation. So how do we write KVL equation? VCC is equal to the VCE plus ICRC here. So now find out IC current. IC is equal to the VCC minus VCE divided by RC values. So if here VCE is equal to 0, okay, here. So due to the gate current, so this if EC is equal to 0, so then what will happen here? So this is a IC is equal to the VCC by RC values, okay. And if VCE is equal to, okay, EC is equal to the VCC, so then IC is equal to, so that is equal to 0. Why? Because this is equal to 0, IC is equal to, both are equal, then it will become 0. So now let us draw this point of view. So let us take here VC, here VCE can be controlled. Okay, here this the VCE, where VCE can be controlled. VCE, the controlled by the gate current IC here. So next one, so first one, let us take this part is a VCE, okay, VC, and this current is a IC current. So when this the first point, when EC is equal to 0, so this is equal to 0 and VCC by RC values here. So this is the one point. Now similarly, when VC is equal to VCC, so that is equal to IC is equal to 0. So that is a VCC and IC equal to 0. So now this is a complete the safe operating area here. For low value of the gate current, okay, low value. So per here is a the IC is low, okay, IC is a low. For I value of the gate current, okay, this is the curve here. So this is a IC is a I values here. So now here this region, okay, is known as the cutoff region, okay, cutoff region, and this region is known as a saturation region here. So now it is a saturation the region, and this one is a the cutoff region, okay, cut off, and this is a active region. But we are not using active region. This is only for analog electronics. For power electronics, always we are operating in the cutoff region or saturation region. So when it is operated, the when, so here IGBT is operated, so in cutoff region, okay, in the cutoff region. So then what will happen? So it is act as a open switch, okay, open switch. So when it is open switch means it blocks the positive voltage. So when IGBT is operated in the saturation region, so now in saturation region, so it is act as a closed switch. So when it is a closed switch, it allows the positive amount of the current. So that's why what we conclude here, open switch, IGBT in the cutoff region, it blocks the positive voltage. Okay, it the blocks positive voltage, and the allows the positive current, okay, positive voltage in the off state, allows the positive current in on state, okay, on state here. So this is in case of the, so this is the off state, okay, off state, and this one is a in on state. So this is a very important point, all of you getting? So whenever IGBT is operated in the cutoff region, so it acts as a open switch. So here it blocks the positive voltages here. Whenever IGBT is operated in the saturation region, it allows the current from the collector to emitter. So that means it allows the positive amount of the current. Okay, got it? All of you? Okay. So now tell me what are the features? Features of IGBT. Very important. Features of IGBT. Okay. Now tell me, is it a fully controlled, uncontrolled, or semi-controlled? It is fully controlled. Very good. So it is a fully controlled, device. Got it? And second one, is it unipolar or bipolar? Why? Because your gate can control. Okay, IZ can be controlled this way. This is the why it is fully controlled here. On state and off state. Off state can be controlled by IZ gate current. That's why it is a the fully controlled device. Okay, and it is a unipolar. Okay, it allows the only part here. It blocks the positive voltage. That's why it is called as a the unipolar switch. And next one, it is a unidirectional switch. Unidirectional switch. Okay, and third one, fourth one here, safe operating area here. So that is first quadrant. Safe operating area is the first quadrant. And fifth one, is it a DC switch or AC switch? It allows the positive current only. So that's why it is the DC switch. Okay, DC switch. And next one, it is a minority carrier concentration. Carrier concentration device. Okay. So these are some features of the IGBT. Okay, all of it clear? So today we have discussed about what are the classification, and also we have discussed about the VI characters, ideal VI characteristics of power semiconductor device. Practical characteristics we will discuss. Constructional details, practical characteristics of each device like diode, SCR, triac, power BJT, power MOSFET and IGBT. All the devices for the practical VI characteristics we will discuss whenever we have a discussion about the construction part. Okay, so this is the complete discussion today. So we have some questions, very important type of questions are there. So time is over, so that this complete question part we will discuss in the next class. All the question we can solve by using whatever we have discussed today. ఈ క్వశ్చన్స్ అన్ని కూడా మనం ఈ రోజు డిస్కస్ చేశాం కదా. అన్ని క్వశ్చన్స్, దిస్ వన్ ఇస్ ద గేట్ 2003 క్వశ్చన్ based on the ideal characteristics. This question is also based on the ideal characteristics. Okay, this question is also based on the for 2 marks ideal characteristics. Okay, and this question is also based on the ideal characteristics. ఇలా ఒక ఫస్ట్ చాప్టర్స్ లో అట్లీస్ట్ ఒక 10 క్వశ్చన్స్ ఉన్నాయి. ప్రీవియస్ గేట్ క్వశ్చన్ అన్ని కూడా ఈరోజు మనం డిస్కస్ చేశాం కదా. ఆ కాన్సెప్ట్ తో ఈ క్వశ్చన్స్ అన్ని చేయొచ్చు. ఓకే, ఈ క్వశ్చన్స్ అన్ని కూడా నెక్స్ట్ క్లాస్ లో డిస్కస్ చేద్దాం. Okay, we will discuss everything, every question based on this concept in the next class. No, tomorrow you don't have any special class. Day after tomorrow you have a special class. I will update in the channel. Pawan, tomorrow you don't have any special class. Day after tomorrow you have a class. ఈ క్వశ్చన్స్ అన్ని కూడా నెక్స్ట్ క్లాస్ లో, నెక్స్ట్ సండే క్లాస్ ఉంటాయి కదా, అప్పటి వరకు మీకు ఈ కంప్లీట్ డిస్కషన్ ఒకసారి చదవండి, మళ్ళీ క్లాస్కి రండి. ఆ క్వశ్చన్స్ ఎంత ఈజీగా చేయొచ్చో మేము చెప్తాను మీకు. మీరు ఈ కాన్సెప్ట్ తెలియకపోతే ఈ క్వశ్చన్ చేయలేము. ఓన్లీ ఇవన్నీ కూడా ఐడియల్ క్యారెక్టర్స్ పైనే చేయొచ్చు. చాలా క్వశ్చన్స్ ఉన్నాయి ఈ కాన్సెప్ట్ పైన. క్వశ్చన్స్ అన్ని కూడా సేమ్ ఐడియల్ విఐ క్యారెక్టర్స్ పైనే ఉంటాయి. ప్రతి కూడా 2 మార్క్స్ క్వశ్చన్, 1 మార్క్ క్వశ్చన్స్ ఉన్నాయి. ప్రతి క్వశ్చన్ we can discuss in the next class. The next power electronics class will be on Sunday, next Sunday. Sorry, next Saturday. Saturday and Sunday. Okay? All of you clear? Everyone? All the questions we can solve in the next class. Okay, this is our Creatrix official channel. Please join in this channel. And Unacademy Gate Telugu channel. Any updates from the Unacademy Gate Telugu you can get from the channel, and also will get the class notes from the channel here. And this is our the channels: Unacademy Gate Telugu, Unacademy Civil, Unacademy Gate Mechanical, Creatrix Gate, Unacademy SSC JE, Unacademy Computer Science, Unacademy Gate questions. So here you will get all the questions from the channel. Electrical junction. So from the channel you will get some concept. The next one here, Unacademy Engineering Foundation course. So Engineering Patashala. Okay, got it? Thank you all. Thank you very much. Okay, thank you all. Thank you very much, everyone.